Well, hello everyone, and welcome to Digital++. This first series is about building a metaverse. Well, in this series I will build a basic but fully functional multiplayer VR application in Unity. This is part 2. If you haven't watched part 1 yet, I sincerely encourage you to watch that first, as we'll continue here where we left off in the previous video. If you decide to code along, by the end of this video you will have a fully functional baseline VR application that you can use for your multiplayer VR game or even to build your own part of the metaverse. This application will be vendor agnostic, so it will run on any VR system that is supported by Unity. Now let's roll up our sleeves and get into the weeds. But it's probably better just to do something ourselves. So we'll create a small sphere. We will create a small 3D object cylinder. We will create one more cylinder. Well, let's move those to the side. So there we go. Sphere, cylinder, cylinder. There we go. We'll move the head, get at position 0, 0.65, 0, and then the scale should be 0.3. The cylinder, its body, so it'll be at 0, 0, 0, but then the location will be 0.2, and the scale should be also 0.3. If you look at the head, we should make it a bit wider on the y-axis to make it more realistically look like a head, just a tiny little bit. And then this other cylinder, that will actually be the hands. We can make that a bit smaller. Let's move it to 0, 0, 0 for now. Make it 0.1. These are just our hands, right? And we'll move them here, move them to the side. There we go. And a little bit down. You see, I'll move this thing, I'll copy it, and then move the other hand to the other side. There you go. So we'll rename this to right hand. This should be our left hand. This will be our head, and this will be our body. We'll create a new empty object, which we will call avatar, and we'll move the head, body, and hands under the avatar object. And we can actually move the whole avatar around. So we'll move it to 0, 0, 0. Probably just disappeared in the floor. That's probably not good, so I'll move it a little bit. If you remember, we have a prefabs folder, so let's move the avatar into the prefabs folder. Move the avatar over there. We do want to create a material, so let's create a new material. Let's call it avatar head material, and we have to create another material called avatar body material. For the head material, for now, create a color. Let's make it a bit pinkish. This is a nice color for a head. And the body material, we can do the same. See if we can use the same color here. There. So head and body material, and we will move the head material onto there, and then on the body, we move the body material onto the materials part here. And for the hands, we'll do the same. So we'll click both hands, and we'll actually move the avatar body material onto the materials field. So now you see the avatar does have a color. We can even take a picture here. If I have something here like a face, I can move that into the materials folder and move the face onto the albedo field here. But unfortunately, the head is tilted in the wrong way, so we'll now need to move around a little bit, play around with the offsets. I think it's about 0.25 or so, and here minus 0.06. So now our avatar has a head, and we can start using it in our application. That's saved. We've removed the avatar from the scene. Okay, the next section, we are going to install the networking aspects. We've built our small mini metaverse, but it's kind of lonely out there because we're all alone. There's nobody else there that we can interact with. And we'll start to build that. So we go to the package manager and we'll type NetCode. So obviously go to the Unity registry. Version 1.3.1 in this case. So it is installed. No need to import the samples. And we do want to install another package, which is called multiplayer tools. Gives you some capabilities that we want to use later on. So we'll install those as well. Now, before we continue with NetCode, there's a few things we need to talk about. What actually NetCode does is it helps you network your game. And that takes you away from having to do low-level coding on TCP/IP sockets and all kind of ugly things that you really don't want to bother about in building your game. So from that point of view, NetCode really takes away a lot of the pain and is really helpful. There's a lot to consider though, because nothing you would expect to work automatically is automatically working. You'll need to take a couple of steps to make sure that your app really works as you expect. You need to create a network manager object. There's one network manager object in your whole application, and that configures the TCP/IP address and the network transport, either UUNet or the Unity network transport. And those are two options. Then you need to add a network object to your avatar, and that's because if you don't have a network object, then the remote participants will not get to see your avatar. And if you remember, in the design phase, we chose for option 2, which means that we're making the avatar network, and the avatar is just only locally going to be influenced by your XR rig. There's another complexity that once you start moving around your avatar and moving your hands and your head, that's going to be automatically replicated to all of the clients, because NetCode by default does not provide that functionality. So you need to add a client transform component and a network player object to make sure that, first of all your data is replicated over the network, all your movements, so all your rotations, all your positions, and even the scaling will be replicated. But then the last thing is that by default, NetCode for GameObjects is server authoritative. That means nobody is allowed to make any changes unless the server sort of authorizes it. And in our particular game, we want to abandon that because that makes the application and the programming quite more complicated. And we want to make it client authoritative. And for that, we'll implement what we call a client network transform instead of a normal network transform. And we'll show you in a little bit how that will work. So we have installed Unity networking. So we can now start adding an empty object called network manager. It's an empty game object, and then you add a component, type in a network manager. You see a couple of things here. First of things that I mentioned, it needs to have a player prefab. We just created our avatar, right? So we go to our prefabs folder, we move the avatar into the prefabs. And it's important to understand that the network manager will spawn your avatar, and when a client joins remotely, it will also spawn the remote avatar. As I said, we need to select a network transport. There's Unity transport and UNet. So let's go for Unity. By default, Unity transport, IP address 127.0.0.1. It is okay, but we'll need to change that once we start testing with virtual reality glasses. We'll want to enable the allow remote connections. Otherwise, you will not be able to connect in the future from your virtual reality system. So that is done. Now let's go back to, if you remember on the UI, we had a file called launch UI, and there were some actions that we set under host and client button. So now we have the network manager installed. We can start populating it. So double click on this. We can take the debug log message away, and under network manager, you will need to add it first. Unity.network manager using Unity netcode. We need to add that first. It'll automatically add that line there. Just singleton.start host. We will do network manager.singleton.start client. There we go. And I'll save it. And then we go back to our application. It'll compile scripts. So now we have connected our UI scripts and UI buttons to the network manager. Okay, let's do the more complicated work. So now we need to start opening up the avatar. So let's go to prefabs and open up the avatar. So the avatar needs to be networked. We will create a network object. Please note you can only have one network object in the avatar. We add another script and we'll call it client network transform. That doesn't exist yet, so we'll create a new script. There we go. So I'll copy paste the information that we'll need to put in. This is something that's provided by a third party. So it has Unity netcode components. It has used the Unity engine. You create a new namespace called client authority, create a class called client network transform. And the only thing it does is creates an on is server authoritative and returns false. So we'll save that. If you see as it inherits from network transform, it allows you to now synchronize the position, the rotation, and the scale, etc. over the network. Well, we won't change the scale, so we can switch that off. So we do that for the avatar. We want to do the same for the head. So we want to also do a client network transform. And we want to do the same for the body and the left and right, and we actually can select them all and just X, Y, Z. So what that does actually, it replicates not only your avatar itself, but it also replicates the movement of the head, the movement of the body, the left hand and the right hand, so that all your remote participants will be able to see exactly all your movements from your avatar, and also the other way around, you will be able to see the others avatar as well. So that is that part. And the last thing we now need to do, if you remember in our picture, the XR rig needs to control the avatar. So we'll create a new script called network player. So we go to our prefabs, we open our avatar and we create a new component and we'll call it network player. It will be a new script. So we'll click on that. It'll create network player. And let's open that. What we'll need here, because this is a network application, we'll make this network behavior. It doesn't inherit from mono, but it inherits from network behavior. So you should add using unity.netcode for network player, that's connected to your avatar. So that should really be launch the code, not when the avatar is launched, but when the device is spawned on the network. So instead of using void start, we'll use a public override void on network spawn. So what we'll need to do now is a couple of things in this code, and we need to be able to access some variables of the XR rig. And we'll go to the XR origin. There is a hands and controllers manager script. So double click on that first. Some of those variables will need to access those because you want to identify where your hands and your controllers are. So we'll make the enum public. The game object, we also want to make that public. The right hand, the left controller and the right controller, all public. Make sure you also add public mode, left mode and right mode. So these, and then we save it. Now we can start accessing these variables from our network player script, which we will need here. So what I'll do first is I'll create a number of variables that we'll use. I'll copy paste it in and I'll explain what it means. So we'll create a number of references to variables that we'll use in our update function. Now, normally it's not the best way to make a program where you use global variables, but because of the update function here needs to run really lean, we want to make sure that there's as little lookup code in here as possible. And therefore in the on network spawn, we'll identify the pointers to all these controllers and hands and avatar things so that in the update function, we can just use those and assign them without having to do expensive functions like a GameObject or find. So those are things we usually would want to avoid in an update function. We see a hands and controllers manager error message because the system obviously doesn't know yet what it is. So we should be using the Unity Engine XR Interaction Toolkit sample hands because there is where it's defined. Let's look into the prefabs. We see the network player, but there's nothing here where we can fine tune the avatar with. So you may want to have some offsets for your positions and your rotations. So we'll add those here. And we'll create those serialized fields. We'll create factor 3 for the avatar left position, the avatar right position, so that's your left hand, right hand, and the rotation, and for the left and the right hand as well. And then for the head, you want to have a position and a rotation offset. Make sure that the positions are factor 3s and rotations are quaternions. So on the on network spawn, the first thing we want to do because we now just started, and when you start debugging your application, it would be just great to see who's joined my application. So the first thing we want to do is see what is my network object ID, right? So you can do a get component of your network object, and that will provide you a network object ID. So if the avatar is owned by the server, the name of the host, and then the ID of the network component. And if it's a client, it will just provide client and the ID. And this way, once you start the application, you'll be able to see who is the host, who your client are in the Unity console. Then if I am not the owner of this avatar, I can just as well do all the complex logic of connecting my XR rig to the avatar, right? So my XR rig, and we're going to do a GameObject.find. Usually I don't like those too much, but you can run them once in the start function, and we call it XR origin. So we want to find our XR origin, and if it exists, then we can do a debug, because that's always nice to see if something worked or not. And then we'll say found XR origin, and if not, could not find. Oh, there we go. So that's all done. And now we want to really connect the XR rig to the avatar. The hands and controllers manager, so we can find it because it's part of the my XR rig. Get component. It should be a hands and controllers manager. So now we have a link to the actual hands and controllers manager. And then we say the my XR, the left hand pointer is the HACM, because that's the object, and it's the left hand transform dot find, because we want to look into that and we want a direct interactor. Left controller is the HACM dot M underscore left hand, no, left controller dot is a transform. So let's quickly look what we're doing here. So first of all, we're getting a pointer to the object of the hands and controllers manager. And within that, we are going to find a pointer to the left hand and to the left controller. The XR origin has a hands and controllers manager. It has a left hand and a right hand and a left controller and a right controller. So that's what we've been looking for. In the case of a hand, the actual transform position is captured in the direct interactor. In the controller, the actual hand position is not captured in the direct interactor, but in the transform itself. I found that out by just trial and error. Let's do the same here for the right hand. And this is a right controller. The transform. Oops, typo. So we have the right hand, right controller, and then we also still want to add a pointer to my XR camera, because I need to know obviously where my head is located. So we'll do a GameObject.find, and that's where the camera is located and how it's rotated. We need to have it transformed at the camera itself. These are, let's say, pointers to the XR rig. And now we need to find the pointers to avatar. So let's call it AV left. That's the left hand. That's transform.find local avatar. And if you remember, the network player is an object that is a part of the avatar. So I can use transform.find. The AV right is transform.find and the right hand. And then we have the head. So where's the head? That's transform.find. And then the AV body is transform.find. There you go. That completes the start function. So by now we should have pointers that we can use in the update function. Now the important thing to do first is, as quickly as possible, we'll identify whether or not I'm the owner of this avatar or not. If I'm not the owner, and then just return. Stop everything else. Also, if I don't have a XR rig, so if I haven't found my XR rig, we also want to return. On your left hand and your right hand, you can either use your controller or your hand. So we need to figure that out. I'm decided to use a switch left mode, and we can do the same for the right case. Hands and controllers manager dot mode dot motion controller break. In case you have if you have AV left, so if that exists, then you want to make sure that your AV left dot position is actually your my left controller, because this is a controller, right? Dot position plus the avatar left position offset. So what we're trying to do here is you want the position of the left hand of the avatar to be forced to be the position of the left hand controller plus any offset that you defined. So that's the position. Now you also want the rotation, right, to be the same. And you'll do the my XRC dot rotation multiplied by the avatar left rotation offset. And for quaternions, you cannot do a plus. Now we'll copy this thing below, because we now want to do the same for if it is the tracked hand. Then you want not the LC, but the L hand, and the L hand. What you can also do, just to be sure, case dot none, because there's also the possibility that there's no controller and you basically don't want to do anything and you just break out. That's it. Then we create another switch for the right hand, so we'll do exactly the same. Need to move it over here. There you go, the right mode. So now we want to look at the right hand, and if it's a hand control, then we change AV right. Obviously we'll change the right position, and the RC right. And this one needs to be right as well. So now we've moved the hands, and now we are going to move the head and the body. If AV head, if the head exists, hopefully we can find the head. If not, then we're in trouble. Then the AV head dot position my XR cam, because we need to have the cam position, and then we add the avatar head position offset, and the AV head rotation is the my XR cam dot rotation multiplied by the avatar head rotation offset. There's also a body, so if AV body, then what we need to do is the AV body dot position, and we don't change the rotation yet. We can change that later. It's not really crucial. We want to just follow the head position because it needs to go in the same place. We want to add an offset. For now, I'll just do it this way: new vector 3, 0, minus 0.5 and 0. Okay, so that is it. So we want to make sure that the left rotation offset at 90 degrees, and then for the right hand the same as well. Otherwise the hands will be perpendicular to your controllers, and your head rotation that's 180. So let's do a run. Okay, well, I need to go move over here. I'm starting the host. So there you go. And you now see my body is underneath me. My head is obviously moving. So if you look in the scene, you should be able to see that my avatar is moving. All right, so I'll turn on this thing. You see the head is moving with me. You can actually see my hands are moving with me, and I can move around in the space. And when I switch to my hands, but for now at least, it looks like this part is working. Okay, awesome. So a few words on how you should test this environment. So far we've tested with what I call scenario 1, so a Quest link. So I have my Quest or whatever device you have with a link connected to your laptop, and that allows you to see whether your avatar and your XR rig interact properly. Obviously that will not allow you to test any network functionality. So for that you could start using scenario 2. That means you need to run your application in standalone mode. Now, first of all, you need to go to Network Manager and change the IP address. So far we've used 127.0.0.1, which is only valid on this local PC. When you install the client on your headset, this will not function. So you go to a command prompt, your local IP address. In my case, 192.168.2.171. Enter that in here, 192.168.2.171. Now, it is also important to know that your computer has a firewall. So you will need to go to your Wi-Fi settings here. In my case, my Wi-Fi is called SuperGrover, and make sure that your network profile is set to private network and not to public network. Because in public network, the network is too much constrained, and it won't allow any remote access. And you can even, if needed, access here, configure firewall and security settings. When that's done, you now need to compile the application. So you go to build settings and you switch to Android to do switch platform. Now that will take some time. So we'll pause the video here and then come back when it has finished. Okay, so it's now switched and we can now do build and run. We'll go select Android, and then we'll call it Quest, because this is in Quest 2. So I'll call it quest2.apk, and we'll save, and it'll start compiling, and we will pause again and come back when it's done, because it'll take a few minutes. So that took about 6 minutes, and let's now see if we can make this run. So first what I will do is I'll start the host application locally. I can take away the cable from my Oculus Quest, and I'll start as host. And now let's see if I start up my device, if I can connect to it as a client. So now I am here, and I will move around because you will probably be seeing me over there. And there you go, here I am. And I can move around and move my head in all directions and wave. And yeah, so I'm now connected over the network, completely disconnected from my PC with the USB cable. And so this is scenario number 2. And fortunately for us, it all works. Let's stop this for a second. So please, as a reminder for scenario 2, standalone, mind your Windows Defender firewall or any other firewall that you have. Make sure that your incoming traffic from your virtual reality headset is not bouncing off the firewall. Check your IP address in your network manager. If you click client and nothing's happening, 99 out of 100, your IP address is wrong. And also make sure that you check the box allow remote connections in your network manager. You should not forget that. The last scenario, which I won't show here, if you have 2 VR headsets, you should be able to do the same as scenario 2, but then with 2 VR goggles. And with that will allow you to see the movement of the laptop is stuck, right? Because there's no movements there. There's no XR virtual reality system connected to it. So it will just be a dumb avatar sitting there. In scenario 3, you'll be able to see each other's movements and shake hands and these kind of things. The unfortunate thing there is very hard to test for one person, because you would need to basically wear 2 VR headsets, which is very difficult. And so you usually need 2 or more people to try that scenario out. But that will allow you to at least make sure that you've covered all possible scenarios. So that about wraps it up for this series, where we built a very simple but fully functional multiplayer VR application in Unity. To do a quick recap, we created a project and then implemented and configured all packages. We created a very simple user interface to start as a host or as a client and with a debug log. Then we built a very simple avatar from basic 3D building blocks. We installed NetCode for GameObjects and then configured it. We then built some C# scripts to manage the UI, to authorize the clients, and a little bit more complicated code to let the VR system move our avatar. We continued with adding and configuring components to our avatar to enable it for networking. And then finally, we reviewed some testing scenarios. I hope you enjoyed these 2 videos, and if you did, please like or subscribe to my channel. In future videos, we can enhance the avatar and, for example, look at machine learning with TensorFlow to generate parts of it so that it's much more realistic than it is today. From here, with the application that we have, there's a truckload of things we can build in our journey of building a metaverse, and it's really exciting. So please feel free to post any questions. I'll be more than happy to help where I can. Thank you and goodbye.